Alright, time for another math. Easy. So we're going to discuss some economics and basically look at marginal costs and what they are. Basically, to start off, let's say we're given a cost function here, and let's say it's called c of x, or is a function of x, and what this means is just that it's the total cost to produce x amount of items. In this case, items, you have a car or what, or a toothbrush or whatnot. So the number of those that you produce, and this is total cost here. So now let's say you had x1 amount of items, and then you increase production to x2 amount of items. Then basically the average rate change of the total cost is just going to be, well, delta c over delta x, and this is just going to be equal to the cost of producing x2 amount. In this case, let's say you increase from to 10 from, let's say, 5 cars or whatnot. So then just minus cost of producing x1 amount, and then you just divide it by x squared minus x1. And then you could also write this as, well, x2, remember, is just equal to x1. Let's say it's plus delta x, or just the change of it. So if you were given that, then basically this is equals to c of x1 plus delta x minus c of x1, yeah, and divided by delta x here. And then recall from the definition of derivative, basically it's something similar to this. And then the marginal cost in this case is when delta x goes to 0. I'll just write that down here. Yeah, so the marginal cost is just the derivative, or it's equal to limit as delta x approaches 0 of the above function, and this is equal to dc over dx, and this is the instantaneous change, or the rate change of the costs as you produce more items, and this is, yeah, just a derivative. That's marginal cost here. But the problem in real life is that you don't really have items that are like, you don't have delta x going to 0 in real life, because usually they're integers, because you'll have one car or one toothbrush, and you're not going to have half of a toothbrush or whatnot. So it's cost of producing one full one. So if we let's say delta x equal to 1, and let's say we have n items, and let's say you have a large amount, large compared to delta x, oh yeah, or delta x equals to 1. So you have n items, just say, let's say 1,000 or whatnot, so it's large compared to it. So basically the derivative, is just roughly equal to, or just c prime of n items, or the derivative, or the marginal cost is approximately just plugging in this delta x inside our average rate of change function there, this one right here. So we're gonna get c of n plus 1 minus c of n, and remember it's divided by 1 here, but that doesn't really affect it in any way, so I just get rid of that one. So this is what we're left with. So what this says is, because if you look at this one, this is the cost of producing n plus 1 more item minus the cost of n items. So this is, okay, so the marginal cost of this could equal to, or the marginal cost of producing n items, what this just means is just equal to the cost to produce one more item. And then, so this is, yeah, because we approximated by this, so that just equals to that, or the n plus first item. And just get rid of this I there. So if you kind of get this around your head, yeah, so just write this down here. So now let's say, actually, when we look at the cost function here, it's usually written as a polynomial. In this case, a plus, let's say, b of x plus c of x squared plus dx cubed. So this is usually written as a polynomial, and a is usually given as, yeah, a is usually given as overhead costs, and b, c, and d are usually given as raw materials or labor, or etc. costs. And the reason for this, because for labor they usually have the higher powers here, because the marginal cost, you'll still have a cost, and then if the higher one, you're gonna have a higher marginal cost per the amount of items, because it just means that even if you're producing, let's say, one more car, you're still gonna have to pay labor for that one more car, whereas overhead costs and stuff like that usually don't have the higher powers, because usually the overhead cost of producing one more is usually negligible compared to labor and whatnot, because you already done the overhead stuff, so it's all done, so it's usually 0. So now if let's say we're getting an example of a company has this cost function they calculated, it's 10,000, let's say it's dollars, plus 5x plus 0.01x squared here. So now if we were to take the marginal cost, we just take the derivative. Remember, it's approximately, yeah, the derivative here, we're going to get 5x. In this case, yeah, the marginal cost is the derivative, so this one, just take the derivative. I mean, I get rid of that x here. This one's going to be 0, this is going to be 5, this is going to be, well, 0.02x. And then if you were asked to find the marginal cost at 500 units or 500 items here, then we just plug this into that function here. We're going to get C of 500 is equal to, well, 5 plus 0.02500. Remember, this 500, this 0.2 is just going to be equal to 5 plus, well, this is 2 over 100 times 500. This is going to be 1,000 divided by 100. This is just going to be 10. And we're just going to get 15, this is numbers, dollars per item here. So this is the marginal cost to produce one more item at 500 items. And remember, this is all it is saying is just a rate change of the cost function at 500 units here. But since, and this is roughly just a derivative there, so basically it's roughly the marginal cost, because in the actual cost to produce 501 is not going to be this one, because if you put actual cost here, and you can calculate the actual cost just by basically plugging in, let's say 501, yeah, minus cost of basically 500 units, and you just plug it into our main equation here, which we were given 10,000 plus 5x plus 0.01. You just put 10,000. If you just plug in both equations, you're going to have 10,000 plus this minus the cost to produce 500 units, and this is just going to, well, the 10,000s cancel. You could collect the like terms. In this case, the 5. Yeah, just the 5. And we're going to get 5 times bracket 501 minus 500. And then like terms in this case is going to be 0.01, 501 squared minus 500 squared. And this one just equals to 5. This is going to be equal to 5 plus, well, 5 plus, well, we'll just put this in the Google calculator. 5.01 times 501 squared minus 500 squared, and this just equals to, well, 10.01 here, and then this just equals to 15 dollars 0.01. So this is the actual cost to produce one more item at 500, because remember, this one is just a derivative at this, and we just extended using the derivative basically all the way to one item, and it's roughly that. So this is basically, yeah, approximately 15, and the marginal cost is pretty accurate here, where we just let delta x equals to 1 here, because remember, we're using the rate change at 500, and we're just expanding it out to 501, so we could just use this one here. And also further in economics, there you also have marginal demand. Yeah, you have marginal demand, marginal revenue, marginal profit, and these are just the derivatives of the demand, revenue, and profit functions. And I'll look into these in later videos here, but this is all for today. Hopefully you learned on this one, because you see the calculation for the actual cost is much harder to do than basically taking a derivative here, and then we could just approximate what the next item would be just by using this marginal cost and expanding it out to one full item. And that's just roughly the same thing. So it's much easier to calculation, and basically hopefully you learned this. You can download these notes like always in the Dropbox link below. Let me know if it doesn't work, but that's all for today, and stay tuned for another math easy solution.